Okay, so you can all see the screen now. You can type in chat. Yeah, we can see the screen. Okay, good. Okay. So let's see. Let's do a few more problems. And so I want to point one thing out, and that on question 19, there's supposed to be another X here. So that's error, but I played with it enough. I know there's supposed to be an X there. So anyway, a lot of times people ask, they're like, oh, is that supposed to be another X? And yeah, it is. So let's see. Emilio, you here this morning?
Yes.
Okay, so do you remember which question we got to? Did we get to 16?
Yeah, I think we just finished 15 last time.
Yeah, okay. So let's have you be in charge of 16. And Devara, you're here? Devara?
Hi, yes.
Yeah, and you'll be one of our people for 16 also, okay?
Okay.
Okay, so I will give you all about 5 minutes, and then we'll come back and discuss. Okay, so Devara, you have an answer. And Emilio, do you have an answer?
Yes.
Okay, good. See, at least that's nice. And also, okay, Devara, this is just a little bit of advice. Even if you have it wrong, don't ever say, hey, like, I'm not sure, like, maybe what. I mean, you can if you want, but like in professional life,
Okay.
you know, you always just want to go in there like, this is it, you know, boom, and you know, not show any sort of doubt in your own stuff. And then if it turns out it's not right, well, someone will point it out and it's okay. But yeah, so be confident. Okay, so Devara, what did you get for the answer?
I got 35,112.5.
Okay, so a number. And what about you, Emilia? What did you get?
So I got 132.5, and then it's 278 for the Y.
Oh, yeah, but that's just a point of intersection, right? You still have to calculate the difference between the under
Yeah, got
curve areas. Okay. So what did you get for the point of intersection, Devara?
It was 278.
And the Y value. So it's X and Y.
Oh,
right?
the X would be 132.5, and
Yeah,
the Y
yeah.
would be 278.
Yeah. And here we need the X's, right? So I don't know what your picture looks like, but I'll show you what I would do, and then tell me what you did. Okay. So if I was going to do this, like I said, first thing I would do is graph it. And there are a couple of different things you can do, but this is you know, probably the easiest. There's y. And there's x. And I'll pick. So we've got okay, can you see my illustration, Devara?
No, I see the questions.
Oh, okay. How about now?
Yeah.
Okay. And so in this example, we have a downward sloping line and an upward sloping line, right? And the are you with me, Emilio and Devara?
Yeah.
Yes.
Do you guys does your illustration look like this?
Yeah.
Yeah.
Okay. And so what was the y-intercept for the upward sloping one? Anybody?
For which one?
The upward sloping one.
Oh, it's 13.
Okay. So there's 13. And obviously, this is what happens when x is equal to 0, right? Yeah.
Right.
Yeah.
Right. And then where they intersect, so it's pretty common to label the point of intersection, and you'll see me do this a lot, as x star. And then you both agreed, and what did you say it was, Emilio? 1.
For the X or the Y?
The X. I have X star on the illustration.
I got 32.5.
32.5. Is that what you got too, Devara?
No, sorry, 132.5. Sorry.
Yeah, that's what I thought. Okay, 132.5. And that's what you got also, Devara, right?
Yeah.
Yeah. So and then you all should be able to see. So I'm just drawing this like this. So that's that point right there. And I'll try to even out the illustration a little bit. Okay. Now here's the next part, and it's not really tricky. But you see how I drew the picture, and now the difference between the under curve areas. So you help me out with this, Devara, for a minute, okay? Are you with me?
Yeah.
Okay, can you see my my little arrow?
Mm-hmm.
So the green line, the downward sloping one, here's the area under it, right? From 0 to x equals 1, 32.5,
Mm-hmm.
going all the way down. Was that the trapezoid you were talking about?
Yeah.
Yeah. And so it's all this area here. I'm not shading it in because that takes a while, and I don't want to do it till kind of we settle that. So I would take all the area underneath the green line up to x equals 132.5, and that would be the trapezoid in there. Now, Emilio, you with me?
Yeah.
You can do this part. Now, the area underneath the pink line, right? It's down here, right?
Right.
Right. And it's another trapezoid, right? So now the difference between those two areas. And there are, again, a lot of questions in this class that you'll be taking the difference between the area underneath the demand curve and the area underneath the supply curve. So it won't say the under the curve areas, but it's the same calculation. It's just, it'll be different language, right? And it won't even say the difference between the under curve areas, because we have special names for those, and you'll learn those names as we go forward in the class. But just for getting us started, right? So I'll say this is the green area, right? So the difference between them is A and, oh, it's not gonna let me do that. So, oh, I know what I can do. Hold on a minute. A, if I want to do different colors, I have to do it like this. Come on. Okay, so that's the area underneath the green, right? Okay, minus B, the area underneath the pink. And let's see. And can you see how the difference then is this triangle? Do you see what I mean, Emilio and Devara?
Mm-hmm.
Mm-hmm.
So in this case, you just have to calculate the area of this triangle. And this is why I don't like doing the shading, because it takes forever to get it all in. So. Okay. So and okay. So do you think you both can calculate that? That's pretty easy, right?
Yeah.
Okay, so did you both calculate it?
Yes.
Okay, and you have yours, Emilio?
Yeah.
Okay, so Devara, why don't you tell me what you got first?
I got 35,112.5.
And what about you, Emilio?
Yeah, I got the same thing.
Okay, so let's look. Ta-da! This is me clapping for you.
Yeah, it sounds like
Okay,
it was pretty straightforward.
it is, but again, I mean, it takes some interpretation, but if you ask me, the key to every math problem, but I don't mean every math problem you have to graph, but the reason why graphing really helps because a lot of the stuff that we're doing ends up having a visual interpretation. And again, I should point out that when you do the assessments on Ignithium, you are going to work through these problems and you're going to demonstrate your work and upload that to Blackboard, right? But also I ask, and it's about 15% of your grade, I ask you some additional questions that are just graphs for you to do, because that's an essential skill for an economist. So graphing will help you solve the problems, but you're going to have to do some graphs on your own anyway for the exam. So might as well start practicing. But the way to solve like kind of any math problem is start with what you know. And so in this case, right, you can see the two lines and you know how to graph them. And then like you did, Amelia, and Devar, you can find the point of intersection. You know that. You start putting the pieces together, it's kind of like a puzzle. And then, boom, it kind of hits you, the puzzle comes together. So yeah, there aren't any of these problems that aren't straightforward if you do it that way. Okay, so any questions about number 16? No. Okay, then I will move on. So Andres, you here this morning?
Yeah, I'm here.
Okay, good. So I'll put you in charge of 17.
Okay.
And on Twee, you here this morning? On Twee?
Yeah, I'm here.
Okay, so I'll put you in charge of number 17 also. And then I'll give you both about 5 minutes, okay? And let's see. Chinlin Zhang, you here?
Yeah.
Okay, I'm gonna put you in 18. Okay.
Yeah.
Together with Shelby, you here?
Yeah, I'm here.
Okay, so I'll put you on 18 together with Chinlin, okay? And we'll work on them all, okay? That we'll go through it a little bit quicker this way. Okay, see you guys in 5 minutes. Okay. Let's go ahead and see what kind of progress is being made at 17. So Andres and Antwi, you said you were both just about finished with your calculations. Did you guys finish?
Yeah, I finished.
Okay.
So
And Antwi?
the graph, I graphed it.
Okay.
And it was like I went up 5 and then across on 40.
Okay, so you're still working on the graphing part. Is that right?
I'm trying to graph. I'm just trying to put it into trying to separate because so like I was trying to do so when I graphed it, it became like a trapezoid. So
Okay.
I was trying to calculate the trapezoid rule formula, which is
Okay.
A plus B over 2.
Okay. I see. Okay. Well, I don't know because I haven't graphed it yet, and so yeah. So go ahead and you can finish it up, and I'll talk to Andres for a minute, and you can give comments if you have them. So Andres, so you want to tell us what your answer is?
I got 3,200.
3,200. Okay. Now, how did you do it? Did you do what Antwi's doing? Did you go ahead and graph it?
Yeah, I graphed it.
Okay. So let me do this really quickly. We'll go back to the whiteboard and so let's try. To graph this. So you tell me what your graph looks like. I remember, so one of the equations is y is equal to 5. Yeah. So that's just going to be a horizontal line, right? And what's the other equation?
Y equals 165 minus 4x.
Okay, so 165 minus 4x. So that's going to be a downward sloping one like this, right?
Yeah.
So it looks like to me, and I don't know, Antwi, if you agree with this. So it said, and I'm not looking at the question right now because I have I have the whiteboard open, but maybe I can do that really quickly. So pause this one and let me go back. And so the question says, what's the area under the downward sloping line and above y is equal to 5? And it's true that, you know, we can take the difference of you know, two areas separately, but it seems sort of easier, right? To just go ahead and I'll do this in, I guess, pink, right? And just see this triangle here, right? What do you think, Antwi?
Yeah, that was my fault. I was trying to take it under the 5 and under the 165 minus 4 curve. I didn't read the question right, sorry.
Yeah. So yeah, so implicitly in the question, because the question says, you know, above the y equals 5 line and below the other line, and the pink area is really the only one that qualifies, right? Any other area that we might look at on the graph, it doesn't really meet both of those conditions. So we have to go back and calculate the point of intersection again. Go ahead.
I'm not seeing anything on the blackboard.
Oh, hold on. Okay. Okay. There. How's that?
Yeah, it's better. Yeah.
Okay. So the pink area, right? Thanks for letting me know. These controls I have to be careful with. Yeah. So it's this big triangle here. And so what did you get for the point of intersection, Andres?
I got 40.
Okay, so you got 40. And do you agree, Antwi? It's 40. Yeah, so this would be our x star is equal to 40, right? And so that's the point of intersection. And so then all we have to do is we had over here 165, right?
Mm-hmm.
And then down here we had 4, right? So then we can just apply the formula for the area of a triangle. And did you do it now, Antwi? Antwi?
Professor, the horizontal line is 5.
Yeah, I'm doing it right now.
Oh, the horizontal is 5.
Yeah.
Okay. Well, that makes it even easier. Right. Okay, hold on. I'll change that. There. So I'm going to go ahead and switch. Okay. Do you have it on Twee?
No, it's sorry.
Okay. Well, it's 165 minus 5 is 160 times 40 times a half, right? 1/2 base times height. Boom. You have your calculator? You always have a calculator, but I know you have a phone, so. Do you see on Tweet or no?
Is it 3,200?
Well, I don't know. Let's see. The only reason why I was waiting for you is because I want to make sure that you're on board. Because if you're not, I want to help you. But so let's see. You see, I put 3,200 in to the answer box, and that's what Andres came up with. So. Do you see? I put 3,200 into the answer box.
Yeah, I see it.
Okay, let's see what it says. Oh, says yay. Okay, you guys got it right. Congratulations. Okay, so let's move on to 18. So Chinlin and Shelby, take us home for the win.
So, oh, sorry.
Yeah, go ahead, Shelby. What did you get?
So first I graphed it and it came out to be a triangle, but then I went into using an integral to try to solve to it, but my answer is outrageous. My answer came out to like 68,722.5.
And that's totally fine, but you know what? I'll like I told you before, with the calculus stuff, like if calculating the area of a triangle is so easy, why do that? I mean, does it just like make you feel better? It's so funny.
Well, it's just simpler.
It's like I can't. Oh, you can't tell me that it's simpler to calculate an integral than to calculate the area of a triangle.
I hate graphing. I hate graphing. That's why.
Well, you know what? You gotta disabuse yourself of that. You know, are you an econ major? Most people in the class are.
Yeah.
Okay, come on, right? like you don't want that to be the thing. I mean, honestly, it's kind of like,
right.
you know, so my daughter, and she'll be transferring in just a little bit, and probably to Cal Poly, is an architecture major. That's what she wants to do, architecture and civil engineering. If she was to tell me like, oh, but I just don't like drawing out like the stuff, I'd be like, come on, girl. You know, like if you're gonna be an architect, you gotta like draw your plans. If you're gonna be an economist, you've seen in all the textbooks, it's like graphs all over the place, right?
Yeah.
And so you know, you just gotta like bite the bullet, and it's like learning your spelling words or something like that. You know, you just gotta memorize them.
Yeah, makes sense.
I mean, you just have to, because if you don't, that's like, you know, I don't know, fighting with one hand tied behind your back, or not only that, but like I said, it is an essential skill in that, and you guys don't know all about my background. Obviously, you know, I have a PhD in economics. I've been invited to King's College at Cambridge in the UK, and I've been at the National Bureau of Economic Research, Harvard, and I think most people think I'm a pretty good economist. But I also have done a lot of private sector consulting, and I'm telling you, you know how they say one picture is worth 1,000 words?
Yeah.
If you're dealing with an audience that doesn't know math, then you have to be able to communicate with them. And it's really easy for your audience to see, you know, a graph on a PowerPoint or something like that, and you can explain what's going on, and they can see it. It just draws their attention. So you know, you'll be producing reports and you'll be getting paid good money, and people are going to expect, oh, okay, you know, she's going to show me the demand curve, and she's going to show me how things are changing, and she's going to show me, you know, what the supply looks like in my industry or whatever. And and so anyway, yeah. And I will tell you, though, also, I don't want to completely like discourage you, because doing the calculus and the integrals, I mean, that's really, really good too. In fact, I had one professor tell me, as I was trying to draw him a graph in graduate school, because a lot of times things get more abstract. I said, oh, but one picture is worth 1,000 words. And he said, well, one equation is worth 1,000 pictures. Ooh. So, yeah, like touche, right?
Yeah.
So, and that's right when you're talking to the right audience, but obviously somebody that doesn't really get math, they can relate to, you know, a picture of inventories or things like that, much more easily. And most of the time, that's what, you know, professional economists are paid to do, is to work with the numbers. you know, much the way that an accountant does, you know, for people who are not number people. So anyway, okay. So Chinlin, how are you doing?
I just grabbed graph it, and yeah, it shows a triangle that area that we need.
Yeah, did you guys calculate the area, or did you calculate the area? This one's a little different. What did you get for the area?
2,592.1.
Okay, and what about you, Shelby? Now that you have it, can you see it?
Yeah, that wasn't close to my number at all, so I went wrong somewhere.
Yeah, so you want to go ahead and recalculate the area of the triangle, because it should be pretty straightforward. I mean, you can see on the y-axis, the base of the triangle is be 165 minus 4, so that's going to be 161. All you need is the point of intersection, so the x value, to get the altitude of the triangle, right?
Right. Can you like go through the problem?
Well, tell me which part.
The intersection.
Oh, okay. Well, yeah. Let me do this. We'll go back to the whiteboard and share. Okay, so you can see the whiteboard now, right?
Mm-hmm.
And so I'm just going to modify this a little bit. I'm going to erase. Oh, I don't know if we can do it. Oh, no, it won't let me. Okay. Okay. Okay, so our equations now are a little bit different. I thought it was 5 plus 4x, right?
4 plus 5x.
Oh, 4 plus 5x, yeah, okay. So which is an upward sloping line, right? So there's the 4. And then the other line now is just at 165, right?
Right.
So it's gonna let me do this. So I'm gonna put it like that. And notice again, like my graph is not perfect. It's more an illustration, because, you know, I go from 0 to 4 and I have that much distance, right?
Right.
And so it's not to scale, right? And then I go from 4 to 165 and I have that much distance. So it's not to scale, but that's okay. Because now we have the essential features. Now in terms of the equation, so we have y is equal to 165 and y is equal to 4 plus 5 times x, right? So that's just 165, right? We set the two right-hand side, the ones that correspond to something other than y, because they're both equal to y. 4 plus 5x. You agree?
Yeah.
Yeah. Right. And then it's going to be subtract 4 from both sides. We'll have 161 is equal to 5x. And do you agree with this, Chinlin? Because I'm assuming you did the same thing. So x is equal to 161 divided by 5. And you have your calculator, right, Shelby?
Yeah.
So
divided by 5 is 32.2.
Okay, 32.2. Do you agree, Chinlin?
Yeah, that's exactly what I did. Yeah.
Okay. So I'm going to put that over here. And now I'll change this. What did you say it was, Shelby?
32.2.
0.2. Okay. So that's our point of intersection, and right?
Mm-hmm. And so then after we find the point of intersection, do we plug it back in, or?
Well, no, in this case, you don't have to, because see, and I'll go ahead and kind of highlight this. So can you see the pink highlighter now? I just put a pink dot there. Well, you know that the y value is 165.
Mm-hmm.
Because the equation is y is always equal to 165. So we would normally do like x star and y star, but if one of the equations is a straight line, then we don't have to like substitute it back in. I mean, you could if you wanted to. If you put 32.2 back into this equation, then you'll get 165. But it's kind of obvious from the graph that the point's right there, right?
And then from here, the area, just do the area of a triangle?
Yeah.
Oh. Wow.
So I'm highlighting it in yellow. I hope you can see it. But it's this triangle here.
Mm-hmm.
But I'll tell you, like what we've been doing, you can kind of see. I mean, if you're not starting to pick up a pattern now, it's only because you're not paying attention. You know, we graph these things, we identify an area. The area normally corresponds to some geometric shape, and then we calculate the area. And you're going to do that in the first part of the class. I would say it's 90% of what you're going to do. So now that you've seen it, what did you get for the answer?
I'm calculating. $25.92.
25.
I might be using the wrong numbers.
Well, but why? 165 minus 4 is the base is 161, right?
Mm-hmm.
And then the altitude is just 30. You can see the altitude is the x value where they cross.
Yes, that's my answer.
25.92. And so Chinlin, do you agree?
Yeah, I got 25.92.1.
0.1.
Yeah.
Huh.
That's
so
cool.
And you didn't get a point anything, Shelby?
Let me do it again. I think I did, but I just left it out.
But I don't think you should, because, well, maybe, yeah, maybe, yeah, maybe you should. Is there a 0.1?
Yeah.
There is a 0.1.
Mm-hmm.
Yeah. So, and remember, we want to do dollars and cents on our precision. If you know, I mean, you got to do graphing, but you got to try to be, at least 2 digits precise, because otherwise, we might end up getting the wrong answer because of rounding error. Not always, but it's important to get in that habit. So anyway, so let's go back here. Share 18, and I'll put it in the answer box. 25.92.1. Submit. Yay. Yay. Okay, good job. So I'm not going to do 19 and 20. I do want to let you know that I posted a Turnitin assignment due Monday next week at midnight, which is this assignment, which is the math and graphing assignment 1. And so again, you go to Ignithium, hit refresh a couple times, whatever, get some equations that you like, print it, take a picture of it, whatever, put it in a Word document, take pictures of your work, put them in the Word document, and then at the top, you know, type homework number 1 and your name and, you know, the date, a couple things, and then submit it to turn it in. Again, if you don't put the identifying information typed into the document at the top, then turn it in won't accept it. It's looking for like 20 characters or a couple of words, just because of the way the system works. So I'll ask, does anybody have any questions for me?
Hi, Professor. I just have a quick question about the homework.
Okay.
Yeah, is number 19 like a typo? Because I'm not sure what to do about this x2 equals
yeah,
x1
no, so
plus
actually, I don't
equation.
know, maybe you came in a little bit late, but I said that at the very beginning. It is a typo. There's an X there. Just like there's a typo on number 16, there should be an X there also.
Okay, I understand that, but what about the other part, the x2 equals x1 plus 5?
Okay, but see, so look at the question. So let x1 be the value of x associated with a point of intersection. So between these two equations, right, y is equal to 543 minus 2x and y is equal to 13 plus 2x, there'll be a point of intersection, right? Right. And yeah. and then you're going to have two x's, x1 and x2, and x2 is going to be x1 plus 5. So the difference is, and I'll show you really quickly, we'll go back to the whiteboard. So in all of the ones that we've been working on so far, right? And
so is it just the area between like 0 and x2
no,
and
no. Okay, so let me follow through with this first. Okay, so I'm gonna try to pick a different color so it'll show up.
Or is it between x1 and x2?
Between x1 and x2. Okay, so you can see my blue arrow now.
Yeah.
So all the ones we've been doing up to this point in time have been what you might call interior triangles. They're in here, right? But that one is kind of like an exterior area. It's talking about points over here, right?
Okay, so it's basically that triangle between the point of intersection and 5 units after that. Am I understanding that right?
Yeah,
okay,
that's right. Yeah, so it's going to be this exterior triangle part over here. And again, this might seem a little bit odd because just you're not used to it. It's the language or whatever. But again, going forward, this is exactly the type of stuff that, you know, economists calculate all the time. And so just to kind of be a little bit clearer, I'll change this a little bit for purposes of illustration only. And so yeah, if our point of intersection was there, and we called that x1, and then we moved over 5 units to x2, and we ended up then with an area like this. It's going to be something like this. I don't know that this is going to be the shape, but I don't know if it ends up being exactly like this, but it's going to be something like this. a triangle over here. Okay, does that make sense? I'm looking for feedback.
Yeah, that makes sense. Thanks. Thank you.
Okay, sure. Okay, any other quick questions?
Professor, quick question on number 20. I was wondering how to even do it. I was trying to look it up and reached several dead ends.
Okay, let's take a look. So we have the two equations, we can graph them, right? This one looks a little bit tricky. Let me go ahead. I just want to refresh this one more time and get a different version. That's still a y value of 2. Oh, I know what they're talking about. Yeah, so let's see. Okay, yeah, this one is easier than what it looks like. So, and this is another sort of thing that we do. So that was Michael Barbie, right? You were the one that asked the question, or
yes.
Who asked the question? Okay, so check it out really quickly, right? Oh, I wanted a straight line. So one of the equations always ends up having intercept of 2, right? So it's like that. You follow me, Michael? So that's a 2, right? On the y-axis. Does that make sense? I'm not getting any feedback from you, Michael.
I'm sorry, what was the question?
I said, okay, so one of the equations is always an upward sloping equation with a vertical intercept of 2.
Oh, okay.
Yeah, right? I
right.
mean, okay. And the other one is some other equation like this. We don't know what the y-intercept varies, but it's just downward sloping, right? Are you with me, Michael?
Yes.
Okay, do you agree, or you just?
No, I agree.
Okay, so then it's asking the x value distance.
Okay, at the y equals 2 level. Okay.
Yeah, right.
So just plug 2 into the other downward slope.
Well, I think from here you can figure it out, but yeah. So they're asking the distance between the x values when y is at 2 between the two equations. Okay. And we end up doing that a lot too. You know, again, these are just preliminary questions that I picked because as we go through the class, there's going to be lots of cases where you've got to like calculate that distance or you've got to calculate this distance. Do you remember, Michael, the concept of excess demand and excess supply from principles? Maybe not.
Somewhat has something to do with shortage and surplus.
Yeah, exactly.
Yeah.
So, but that's what we were always calculating, right? Those distances, yes. Right? For like price ceilings and price floors. Okay. Well, good job. And I'm going to go ahead and